Hi everyone, I welcome you back to what is part 2 of our TVC prototype demonstrator build. Man, that's a long word. Today we're gonna have a quick look at the code, and then we're gonna look how good the code is working with our electronics we built in the last video. What I'm using for programming today is just the basic Arduino program you probably all already have seen or have used in the past. Let's start at the top. I am using a standard library for our MCP3008. I technically could program that by myself, but why would I do that if there's a lot of people out there who already have done it much better before me. Down here in our setup, we first start a serial communication with the computer, and then I define the 4 output pins to our motor drivers. So pin 42, 43, 44 and 45. And a little bit lower we have the SPI startup command, where we could technically define our own SPI pins, but we don't really need that. We're just gonna use the ones the Arduino gives us by default. Alright, let's jump down to the loop. Our program is basically just a big for loop that switches back and forth between the motor drivers and the corresponding potentiometers. So if we're running this for loop, we're counting up the number I, and as such walking through the different potentiometers and motor drivers. And luckily, as we have the motor drivers connected close to each other on the Arduino board, we don't have to put in a switch case to jump between them, but can just jump 2 pins further with every loop. Such switching between the motor driver outputs. So the first thing we do into the loop is reading the output of our SPI, so our analog to digital converter. We get a number that represents the resistance given from the potentiometer to the analog digital converter. We also print it up on the screen if a computer is connected, and then we jump down to different if statements. So what we're doing in the if statements is just checking if the value we get from the SPI is somewhere between 700 and 400. If it's above 700, the one light should be switched on. If it's below 400, the other light is supposed to be switched on. And when it's between those both numbers, it's just gonna be switched off. Again, the little part 2 times I is just to switch between the motor driver outputs, so we don't have to use a switch case. And because they're close enough to each other on the pin numbers, we can just do it this way and don't have to make a big fuss about it. So that's already the program. It's completely basic. Probably everybody could do it by themselves. But it doesn't have to be fancy. It just has to prove that our electronics are connected up correctly. So we're gonna switch over to the table again and see how it runs. We now loaded the code onto our Arduino and it's perfectly ready to run. Just as a quick recap for everybody that maybe forgot within the time or hasn't seen our first video yet, what we have here is our TVC controller prototype. These electronics are going to control linear motors that in turn are going to steer our motors thrust vectoring. It's made up of a CPU, in this case our Arduino. It has 2 motor drivers for the 2 axes on which our TVC is going to move, and it has 2 potentiometers which are simulating the potentiometers inside the linear motors, with which you can measure how far the linear motor is actually extended. Over here we basically just have some LEDs which are going to show us which direction a supposed motor would currently turn, to see if our output signals are correct. We now loaded the code, which we just looked at, onto our Arduino, and now it's time to power the whole thing up. We're going to use the power supply over in the left upper corner, which you probably only can see as a big gray box. It can put out up to 5 amps at up to 25 volts, so it's quite powerful. We obviously don't need all of that power, but we are going to feed our whole system with 12 volts, as it would happen in the rocket. I hope you can make out that we're currently running at about 12.3 volts. 12.3 volts are obviously a little bit higher than 12 volts, but that's perfectly fine, as our DC-DC converter can actually step down voltage from up to 30 volts. So we're perfectly in the limits of its capabilities. Also, I'm going to put on my safety goggles over here, because, as I explained in the last video, these capacitors we put in here tend to blow up if you power them from the wrong direction. And obviously I was very careful to put them in the right way, but you never know, so just better be safe than sorry, because I like my eyes, I want to keep them. So over here we have the 12 volt plus from the yellow cable, which goes over here in the plus 12 volts line. And then we have the ground, which goes in the common ground line. And if everything goes right, now our Arduino should power up and the LEDs should lighten up in pretty much a random pattern, because we do not have set the potentiometers to any certain number yet, but we're gonna test that in a second. Alright, good news. Nothing seems to blow up, so I can put away my goggles again. So now the test would be turning our potentiometers and then see if the lights change, or actually, as we saw in the code earlier, first they switch off and then the other light will switch on. In this case it's switching between green and yellow. So we're gonna start with the right potentiometer. We have to turn it left, counterclockwise to say. Oop, there we go. Both LEDs are off, and if I turn further, boop, the other one turns on. And the other way around works as well. For the other one, oh, what happened there? Oh yeah, right. Because the potentiometers aren't really fixed in this board too good, we have quite some wobbling, changing the resistance, and as such giving a wrong output. In reality, we're gonna have perfect potentiometers in these motors, so let's just ignore that. But as you can see, also here, if I push it down and I turn it, the light is switching correctly. Oop, I actually hit the one on the right, which is also a little bit wobbly, but well, that's not really important. What is important is, this is running perfectly. Maybe a little thing, as you might have noticed, this video looks a lot better. Things are actually visible, and oh my god, you can actually tell apart the different parts and such. I'm now recording this in 4K, so I hope that actually shows. What else is there to say? As some time progressed, we also have some funny new tools. For example, this over here, which looks like some kind of medication. These are actually ball bearings. Let me see if I can get some out there. I'm not quite sure if you can see how small they are, but these ball bearings are actually the ones we're going to put in between our rings of the TVC. So what is currently just solved by some wiggling room is later gonna be solved with these exact ball bearings. They're absolutely cute if you ask me. In other news, we also went shopping a little bit, so we now have this. This is the linear servo or motor, I'm not very consistent with the name of that, I'm sorry, is actually the one which we are going to use in the rocket. It actually came. We still are waiting for 2 more, the smaller ones for the inner cycle, but this is going to be the 300 Newton on the outside cycle. So the one that moves this whole construction this way. I technically could just unplug the LEDs down there and one of the potentiometers and in turn connect this one, but they are quite expensive. This one costs $100. The 2 others for the inner cycle cost just as much each. So I don't really fancy breaking this motor, screwing around with it, not really knowing which way to connect it. And that's pretty much it for today. We had some good looking flashing lights, everything's working, code is fine. In the next video, we're actually going to build our first full TVC prototype. This one is just 50% size. We are going to build a full-sized one with the linear servos, the full electronics, and then start testing. It's going to be awesome. Till then, don't forget to subscribe, hit the bell icon. If you haven't watched it yet, there's the first video where we build all the electronics you see here. Check that out as well. Thanks for watching, and bye bye!